welcome back to part 2 of lesson 3.3 and 3.4. And in this particular lesson, we're going to learn how to solve a lot of the equations and apply some of the properties that you've learned. And they're going to need to be second nature. You're going to need to be able to just look at it and kind of figure out which ones you need. So this is more specifically lesson 3.4. If you want to pause it while you copy some of these down. With equations, we very often go back and forth between exponential to logarithmic, and then we'll solve depending upon the nature of the equation. Sometimes we use the one-to-one property where it's log on both sides, or we have two values and we need to take the log of both sides. You need to check for extraneous solutions, or you can solve by graphing very often and find the zeros or the point of intersection of the two sides of the equation. Let's look at example 6. It says 2/3 raised to the x minus 5 equals 9/4 to the 3x minus 4. Now, I know that they don't have the same base, but I can see some relation there. I can see that maybe I can get there. If I know that 9/4 is really 3/2 squared, correct? And if I'm going to raise that whole value to the 3x minus, or divided by 4, but I'm going to stop right here and I'm going to look to see where I want to go. I want to make both bases the same. I want 2/3 to be my base here. So if I invert that, then I change my exponent to be -2. So I could rewrite this as 2/3 to the -2 times the 3x over 4. So I really have 2/3 to the x minus 5 and 2/3 to the -6x over 4, which reduces to the -3x over 2. And then I can see that the bases are the same. This is that one-to-one property we talked about. Both 2/3. So now I'm simply playing with the exponents. So now I can take the x minus 5 and say that's equal to -3x divided by 2. I want x. So I'm going to take both sides times 2. There are a couple different ways you can do this. I'm going to take both sides by 2 so that when I distribute to all terms here, I'm going to have 2x minus 10 equals -3x, and I can combine my x's like terms, subtract the 2x over here, so I have -10 equals -5x. X must be +2. And you can verify all of these, but it's like a puzzle. You can plug that back in and you can verify that that is the answer. All right, let's try another one. This one says 4 minus, this is example 7, 4 minus 3 on the log of 5x equals 16. All right, couple things I notice. I've got a couple integers here. I've got the 4 and I have the 16, so I think I'm going to combine those right away. And I've got this -3 up front. Let's see, well, let's take care of this problem first. So I subtract 4. I have -3 log 5x equals 12. I could bring the the 3 up, but I think right now I'm just going to divide by -3. That works. Okay, these are gone, and then I just have the log of 5x equals -4. Now this base right here of the log, it's not written, so it's understood to be 10, right? So if I want to rewrite this exponentially, right now it's written logarithmically, I would take 10 to the negative 4 equals 5x. 10 to the negative 4th power equals 5x. Well, 10 to the negative 4th power is 0.0001 equals 5x. And now divide that by 5, and I get 0.00002. If I add a 0 here, then if I divide that 10 by 5, I'm going to get 2. You have to add that 0 there. Okay? Now let's try another example. Okay, example 8 says 6 raised to the 2x plus 4 equals 5 raised to the negative x plus 1. You're thinking, darn it, right away, they don't have the same base, so I can't do that. But if you notice, you can kind of go backwards, and you can take the log of both sides. That was another one of your properties. So if I take the natural log of both sides here, then I can rewrite it by putting this exponent out front, correct? So then I would have, this would be 2x plus 4 times the natural log of 6, and this would be negative x plus 1 times the natural log of 5. Now let's look at the big picture here. We have an x here, we have an x here, and we somehow need to get them together. These are multiplied. So if I can distribute this natural log of 6 to both of these terms, okay, and then I can get the terms with the x on one side, then I can factor the x out and I can solve for it. So what I'm going to do is distribute the natural log of 6 here to both of these terms. That would give me 2x natural log of 6 plus 4 natural log of 6. Remember that 4 can go up, that's really 6 to the 4th power. Here, this becomes negative x times natural log of 5 plus natural log of 5 times 1. Now I'm going to maneuver so that this x term and this x term are on the same side of the equation so that I can factor them out. So basically I'm going to swap these two pieces right there. Okay? So I have 2x natural log of 6 plus x natural log of 5 equals natural log of 5 minus natural log of, and I'm going to rewrite this as 6 to the 4th power. I'm going to bring this term over. Okay? Now this is shaping up nicely. This is division here. I can just put this in the calculator. Okay? These are all just values. I can do them with division. I can just crank it out just the way it is. Over here, I can now factor out the x value that I'm desiring. So if I factor that out, I have x times the natural log of 6 squared. Now look at what we did. We pulled the x out, but the 2 remained, and I kicked the 2 up as the exponent with the power property. Plus, okay, I'm going to factor out the x, and I'll be left with natural log of 5. Now I'm going to divide both sides and move this over here. Now what is this? This is the natural log of, if I just play with this part right here, that's the natural log of 36 times 5. correct? And I'm going to put that over here with the natural log of 5. This is the natural log of 5 divided by 6 to the 4th power, which is 1296, I believe, 1246, I think. Okay? So right here you can do this multiplication. You're going to be moving this factor over here. This is multiplied, so I need to divide it. So x equals this natural log, what I have over here on this side, of 5 divided by 1246 divided by the natural log of 36 times 5 is 180. Okay? And you're going to get estimated answers. We're going to now get negative 1.07. Okay? And it will tell you to what place to round. If not, we would like you to at least round to the hundredths, usually the thousandths place. But you'll see me do it to different places as well. Just pay attention, especially on assessments, if we ask you for a specific place value. All right, let's try another example. All right, this one's a little tricky, and it usually gives people problems, but I want to talk about what you should see, some signs here. When you have a quadratic, you know how you usually had an x squared term, then an x term, and then an integer term. Well, if you'll notice here, this is to the 4th power, and that's to the squared power, and then there's your constant term. So we are going to rework this problem and change it into something that's more familiar. What we're going to do is we are going to let, let's pick a number, a letter. We'll pick V, and we're going to let V equal the x value here towards the e to the 2x. If we do that, if we let this be V, then e to the 4x would be V squared, correct? So we could rewrite this as 4v squared plus 8v minus 5 equals 0. Okay? Now that's an important substitution. I can manage this. This is very easy to manage. This is a little confusing to me. And I can fix this substitution later, but I can make this work very nicely, right? I can factor that. I would have, let's go with 2v, and factors of 5 are just 5 and 1. Let's see, I need an 8, so I need, no, I need that one to be negative. I need 10 minus 2. So we're going to do 10 minus 2. All right. That will give me two equations here. That gives me 2v plus 5 is 0. So v equals negative 5 halves. This gives me 2v minus 1 is 0. So v is positive 1 half. Now I'm going to go back, and I'm going to go back here and pick up this so that I can say, instead of v now, I'm going to substitute e to the 2x. So e to the 2x equals the negative 5 halves. And over here I'll say e to the 2x equals the 1 half. And when I can now use the one-to-one property, and I can take the natural log of both sides, look what happens. The natural log of e to the 2x is just 2x. But here, I can't do that because of the negative. That doesn't exist. Here, the natural log of e to the 2x is 2x. Natural log of 1 half is roughly negative 0.6932. And so I divide both sides by 2, and x is about negative 0.347. Okay? I'm going to set up number 10, and we will do 10 when you come to class. But my videos run long, and so I'm going to stop right now. And we will do this one when you come. I would like you to try to do it on your own. And when you come to class, we'll play with it and figure it out together. Thank you. I'll see you then.